Now we've got our data ready in our Colab notebook and in Google Drive. Let's clean up our notebook and get it more set up towards our steps that we take in a new project system. So what we've done, we've got Colab, we've created a new project folder, we've got our data in there. We actually don't really need to create an environment of tools because Colab already has a lot of them installed for us. Let's try to import some anyway. Because what are we doing? We're working with TensorFlow. And this is what we're doing. We're getting our data into tensors. Yes, we're going to use TensorFlow for that. And we're going to use TensorFlow Hub to pick a model. How about we get our notebook set up for those two in this video? That sounds like a good idea. If we go back to Colab, what we can do, we can pretty up this. Because we don't need to run this zip command, we could delete the cell or we'll just comment it out for now. So we'll run that. We can close this down. Get rid of that, really just tidying up our notebook, getting it ready. What we might do is add a text cell. And we're going to move that up there. And I'm going to put the title in this. So we'll go, I'm going to put a little emoji because it's nice and fun. So we'll go end to end multi-class dog breed classification. And go, this notebook builds an end-to-end multi-class image classifier using TensorFlow 2.0 and TensorFlow Hub. Wonderful. And so let's get our little headings up in here. So problem, data, evaluation, and then features. So this is again from our 6-step workflow. So we might put in here 1, 2, 3, 4. So problem is identifying the breed of a dog given an image of a dog. Now, there's 120 different dogs. I don't know if you can identify that many breeds, but I certainly can't. So imagine, this happened to me the other day, right? I was sitting at the cafe and a dog walks past and I can't even remember the breed name, but someone next to me said, oh, let's make one up. That's an Australian Terrier. Well, that makes sense because I'm Australian. That's an Australian Terrier. I'm like, wow, how did they know that? And then I realized I only know about 3 dog breeds, like German Shepherd, Labrador, and Beagle. I only got that one because I'm reading that. And so this is what dog vision could be used for. If we were trying to build something that could identify, if I was sitting at that cafe and took a photo of that dog, could my machine learning model, the one that we're going to build, tell me what breed it was? So that's our problem. It's like, that's our statement. When I'm sitting at the cafe and I take a photo of a dog, I want to know what breed of dog it is. That's our problem. We're putting it in real life terms, right? And now where's our data? We can get our data. We'll just put a link here from Kaggle. So the data we're using is from Kaggle's dog breed identification competition. Then we'll put a link here. Evaluation. What is our evaluation? So in our head, I want you to think about this before we even look at Kaggle. Because we're working in classification, what is a good evaluation metric for how well our dog vision is performing? Well, one of the default metrics for classification is accuracy, right? So if we could get it pretty accurate at predicting what dog is in a photo, that's a pretty good metric. But let's see what Kaggle says. So if we go to overview, evaluation, submissions are evaluated on a multi-class log loss. What is that between the predicted probability and the observed target? Well, there's a link here, so let's click that. Oh, wow. Okay. Well, these are things you're going to have to deal with in real life, right? You're never always going to go down the right path. 404, and I like how they've done that with some data there. Well, multi-class log loss, let's have a look at the example. We've got ID, which is this long string. We've got a dog breed here, Affenpinscher. Don't mock me for not being able to pronounce that. Afghan Hound, that's an easier one to pronounce. And 0.0083, 0.0. these look like output prediction probabilities of a model, and which they are. So here we go. Oh, if I could just read this, remember, if in doubt, read the documentation or run the code, either or. For each image in the test set, you must predict a probability for each of the different breeds. The file should contain a header and have the following format. Okay, so this is what we're working towards. If we wanted to make a submission, this competition is closed. See, it's a playground prediction competition. But we can still make a submission. Let's work towards that. And that's the file type we need. All right. So if we go back, where were we? Dog vision, evaluation. The evaluation is a file with prediction probabilities for each dog breed of each test image. And then we go here. We'll copy that, put it into dog vision. So if we ever needed to come back, we can. And then some features of the data. Well, we know that they're images, so they're unstructured. But let's have a look at our data. We have 120 different breeds of dogs. So there's 120 different classes. I'm going to copy that. Some information about the data. We're dealing with images. This is the way I want you to start thinking about different projects, right? This doesn't have to be like formal. By the time you've had some practice with problems, you won't need to write this out, but this is a good habit to have, is that you're communicating your work, not just to others. Like if we were to share this notebook, that's a really cool thing about Colab as well. You can share them, but it's communicating it to yourself so you know what you're working towards. Unstructured data. So unstructured data is just anything that isn't in a data frame. So no rows and columns. We're dealing with images, unstructured data. So it's probably best we use deep learning / transfer learning, which is what this project is all about. What else is there about the data? There are 120 breeds of dogs, and because it's multi-class classification, this means there are 120 different classes. Now, if there were only 2 dog breeds, it would be binary classification. If you remember our project on heart disease, that was binary classification. So whether someone has heart disease or not. So if we come back, labels CSV. So 10,222 unique values. Okay. So that means I'm guessing there is 10,222 different images. Okay, so 10,000 training images. You know what we might be able to do is if we have this locally, is go Command I on that. Boom, look at that. Thank you, Mac OS. You might be able to do this in Windows, I'm not entirely sure. We've got 10,358 items. And let's see if my theory was correct. 10,223 in train. I wonder what that is, where the little discrepancy is from there. That's all right, we'll figure it out. We're not worried about that now. We're cooks, not chemists. There are around 10,000 plus images in the training set. There are around 10,000 plus images in the test set. These images have labels. These images have no labels because we'll want to predict them. Wonderful. So this is us setting up our project space. And now I know at the beginning we kind of said we're going to import TensorFlow, but what's more important is getting our heads around what problem we're actually trying to solve before we start bringing in our tooling. So if we go here, unzip the uploaded data into Google Drive. Wonderful. So I'm going to delete this cell. What should we do now? We might as well import TensorFlow because that's what we're working with, right? We come back to our keynote. This is our workflow. We're working with unstructured data. So get our data ready. We've got it uploaded into Google Drive, correct. Get it into Tensors. We're going to use TensorFlow for that. And TensorFlow Hub. So that's what we might as well try and do. We might as well try and import TensorFlow and TensorFlow Hub. How might we do that? So you could do this. If you have any question, you go how to import TensorFlow. I already know, so I'm just going to show you, but that's just an example. Actually, we're working in Colab, so it's better to be a bit more specific in Google Colab. That's just what I would Google. Oh, look at that. A great video. Oh, that's the old TensorFlow logo. So if you see that logo, that's the old TensorFlow logo. We're dealing with TensorFlow 2.0. So we want to import TensorFlow into Colab. Let's put a little heading here. Get our workspace ready. Now the beautiful thing about Colab as well, little tidbit, is that once you do headings in their own cells, you get this little section over here. So we could go right to the top or we could go back to this section. So that's what we're going to do throughout, is just navigate through this. So we want to get our workspace ready. The import, nice and simple. Import TensorFlow as TF. If you ever see TF, just like NumPy is NP, Pandas is PD, TF is short for TensorFlow. We want to go print TF version. And now this is going to tell us what version, because we're after TensorFlow 2. Oh, and look at this, Google Colab. Autocomplete on tap. Thank you, but we're going to try and avoid using autocomplete because we want to practice writing the code ourselves. Let's see what happens. Oh, red text. Too many underscores. That's the first mistake. Oh, we missed out on that red text. That's all right. I'm going to show you. I'm going to restart my runtime. Remember, if you ever see what I just did, if you ever see this come up, you might have to go to runtime, restart runtime. But I'm going to just show you. We don't have to worry about that cell because we've already unzipped our files. Show you this red text. Hopefully it comes up again. Boom. That's what we were after. So the default version of TensorFlow in Colab will soon switch to TensorFlow 2.x. That's what we want, the new version of TensorFlow. See, you might, if you're watching this video in the future, you might already have TensorFlow 2.x or 2. Whatever. We need 2 something. Because I'm running this, it hasn't switched over yet in Colab. So I'm using TF 1.15, which is not what we want. We want the 2.0 version. I'll see you in the next video. I'll show you a little trick if you don't have TensorFlow 2.0 yet. If you do, keep going, skip the next video. But if you don't, watch the next video.